Sections 4.1, 4.2, and 4.3 about exponents and polynomials. In section 4.1, you will review some rules of exponents. The first of all, we should know what an exponent is. An exponent is just a shorter way of writing a number where we are multiplying that same number by itself. For example, if we had 3 times itself 4 times, we would say that is equivalent to saying 3 raised to the 4th power. The 4 is called the exponent, while the 3 is the base. The first rule is called the product rule. To multiply two exponential expressions that have the same base, all you would do is add the exponents. So if I had the same number being raised to a different exponent, I would only need to take that number, keep it the same, and add the two exponents together. So for example, if I had 3 raised to the 2nd power times 3 raised to the 3rd power, it's the same as saying 3 raised to the 2nd plus 3rd powers, or 3 raised to the 5th power. Here are some other examples using that same product rule. Our variables stay the same, and so since we have the same variable, we add our exponents. So we would add the exponent 4 plus 5 to get c to the 9th power, add the exponent 3 plus 6 to get 3 times a to the 9th power, and add the exponents above the w, 2 plus 5, multiplying our coefficients, 4 times 2, leaving us with 8w raised to the 7th power. Here is an example where we're multiplying different sets of expressions together. 5ab times negative 1/3 a times 9b squared. What we can do first is we can multiply 5ab times negative 1/3 a times 9b squared. This first section did not change. It is the same as above. Next, we can write it as 5 times negative 1/3 times 9. So what we've done is we've taken all of the numbers in front of our variables, the coefficients, and we are able to multiply these three because they are just numbers. We would say 5 times 1/3, negative 1/3 times 9. Well, if I can break that down, I know 9 times 1/3, or 9 divided by 3, would be negative 3, because it's a negative. Negative 3 times 5 would give me negative 15. So that's where my whole number negative 15 comes from. Along the right, we took all of our variables and grouped them together by similarity. A times A, that's in the first parenthesis here. B times B squared is in the second parenthesis here. And since both of these a's are raised to the 1st power, I would add 1 plus 1 to get a to the 2nd power, and the b to the 1st power plus the 2nd power, 1 plus 2 is 3. So I'm left with b cubed. So my final answer is negative 15 a squared b cubed. The second rule is called the quotient rule. When we have the same coefficient on the top and on the bottom, or the same variable, we can subtract the exponents, the top exponent minus the bottom exponent, as long as our base value is not equal to 0. Here are some examples. You will see in example A that both values that are being raised to an exponent are equal to 3. So we can say 6 is the top exponent minus the bottom minus 2 is now equal to 3 raised to the 4th power. Y raised to the 7th power divided by y raised to the 4th power, I would just subtract 7 minus 4, top minus bottom, and I would be left with 3. Think of this. If we had 7 y's across the top and 4 y's being multiplied across the bottom, and we canceled them out, we would be left with 3 y's remaining in the top. And that is why we're left with y raised to the third power. The quotient rule, part 2, we can use this form if the larger exponent is in the denominator. So before, the larger exponent was in the numerator, and all we did was subtract. But if we subtract and get a value that is negative, and it's an exponent, for example, if I had y raised to the negative 7th value, when I have a negative exponent, to make it positive, I have to write it as a fraction. And to do that, I would write it as a fraction under 1. So this would be 1 over y to the 7th power. Writing it as its reciprocal makes that value positive. And that's what this example is showing here. Let's look at some with some numbers. So if I did 2 minus 9, I would be left with 3 to the negative 7th power. And to make that as simplified as possible, I want to get rid of the negative 7th power. And to do that, I can write it as its reciprocal as 1 over 3 to the 7th positive power. A shortcut way to do that is to begin with 1 in the numerator and subtract the exponents in the denominator, so that way your value automatically is positive and you don't have to write the reciprocal. In this case, for section B, z is already negative, so our coefficient is going to continue to stay negative all the way until the end of our solution, even though our exponents would have become a negative value if we subtracted 6 minus 11. So in that case, we write the reciprocal and do 11 minus 6 to make sure that our exponent is also not negative. Here are just some more examples. If we wanted to divide x cubed times y squared divided by 5x times y to the 6th power, we keep our 5 the same, the coefficient. There's no number in the numerator that we are dividing by. For the exponents of x, our similar variable here of x, we would say 3 minus 1, since it's the larger exponent is in the top. 3 minus 1 is 2, so we're left with x squared, or x to the 2nd power. And in the denominator, we would have 2 and 6. The top number is smaller, so 6 minus 2 is 4. Really, if we wrote this out, we would say there are 6 y's in the bottom, there are 2 in the top. They cancel out to equal 1, and we're left with 4 y's still in the denominator. 5 times y to the 4th power. Our next example B, we can divide 3/12 is our fraction. That simplifies to 1/4. Both numbers are divisible by 3. 3 divided by 3 is 1, and 12 divided by 3 is 4. There would be 6 minus 2 is 4. There would be x raised to the 4th power remaining for our x's. And 8, our exponent of 8 minus 5 gives us a remainder of y to the 3rd power for our exponent in the denominator. The quotient rule, or when we're dividing, we get an answer called a quotient. Part 3, if we have x to a power and the same value raised to the same power, it would be equivalent to, say, x raised to the 0 power, which always equals 1. So this is the same as saying 4 divided by 4 equals 1. Any number raised to a 0 power also equals 1. That's one of our power rules, as long as our number is not 0. We cannot raise a 0 to a 0 power. It's an undefined value. So here's an example here. 15 raised to the 12th power over that same value is equal to 1. In the second example, we have a cubed, so we would say 3 minus 2 is 1, times b to the 0, b to the 0 equals 1, so that's where we get the times 1. A raised to the 1st power is the same as a. A to the 1st power equals a. Okay, next we can talk about raising a power. So if I have a number that is already raised to a power and we raise that value to a power, all we do is keep the base the same and multiply the exponents, a times b. So here are some examples. We just multiply 5 times 3 to get 15. And the second one, 3 times 3 equals 9. If we have a product, so we have two numbers that are being multiplied inside, and then they're raised to a power, all we do is distribute that power to each separate number. So here's an example. I would raise 2 to the third power, and then also raise c to the third power. And that would give me 2 times 2 times 2, which is equal to 8, c cubed. I would raise -5 to the second power, and x to the second power, and y to the second power, which would give me 25. -5 times -5 equals a positive 25, x squared, y squared. I would raise 4 to the third power, x to the third power, and y squared to the third power. That would give me 3 times 3 is 9, 2 times 3 is 6, and 4 raised to the third power is 4 times 4 times 4, which is 64. If we are raising a power, a quotient raised to a power, so we have a division problem that is being raised to a power, again, you distribute that power to both values, x raised to the a power and y raised to the a power, as long as the denominator is not equal to 0. This will work. So for the first one, we would just say x to the fourth, y to the fourth. And for the second one, we would distribute that across both the 3 and the a. So we would have 3 to the fourth, a to the third raised to the fourth. 3 to the fourth power equals 81. With our powers here, we would multiply. 4 times 3 is 12, so we get 81, a to the 12th power. And in the denominator, we would have b squared raised to the 4th power. We multiply 4 times 2 to give us 8. And we cannot simplify this any further because our variables are not the same. Last example here, we are asked to simplify, so we have to use some of these rules that we've learned in the previous section to do so. We are asked to simplify -3x squared times z to the 0 power divided by y to the third raised to the 4th power. So we can simplify inside the parentheses first. So if we do that, we can look and see, well, z to the 0 power would be equal to 1, so that would cancel out. And I'm left with -3x squared in the numerator. The denominator stays the same. We're still raising it to the 4th power. The next thing we can do is distribute this power to every value and variable inside the top and bottom. So I'd have -3 raised to the 4th, x squared raised to the 4th, which would give us 2 times 4, which is 8, and y cubed raised to the 4th, which would be 3 times 4, which is 12. And lastly, we can multiply -3 raised to the 4th power would give us a positive 81. X to the 8th stays the same, and so does y to the 12th power would stay the same. I'm going to break up these videos so they're not extremely long, and I will do section 4.2 in another video.